What if I tell you, the quadratic equation you solve in school today, x squared plus bx plus c equals 0, is not just a formula. It is a story that is almost 4,000 years old. It did not begin in modern classrooms. It did not begin with calculators, and it did not even begin with algebraic symbols. It began with clay tablets, land measurement, trade, geometry, and the human need to solve real-life problems. This is a journey of quadratic equations, from the Babylonians to India to the birth of algebra, and finally to the modern formula we use today. Before we enter history, let us first understand the basic idea. A quadratic equation is an equation where the highest power of the unknown is 2. For example, x squared plus 5x plus 6 equals 0. Hey, the term x squared is a reason this is called a quadratic equation. The word quadratic comes from a Latin word meaning square, and this is very important because in ancient times, people did not write equations using symbols like x, a, b, or c. They understood these problems through shapes, squares, rectangles, areas, and lengths. So in the beginning, quadratic equations were not written as algebra. They were imagined as geometry. Now let us go back almost 4,000 years. Around 1800 BCE, the Babylonians were already solving problems that we would call quadratic equations today. But here is the interesting part. They did not write equations like this. X squared plus x equals 12. Instead, they describe problems in words. A problem might sound like this. The area of a square, together with its side, gives a certain number. Find the side. Today, we would write this as x squared plus x equals 12. But the Babylonians did not need modern symbols. They used step-by-step numerical methods. And surprisingly, many of their methods were very close to what we now call completing the square. Think about that for a second. Thousands of years before modern algebra, people were already solving quadratic-type problems. Not because they wanted to pass exams, but because they needed mathematics for land, measurement, construction, and trade. So the first chapter of quadratic equations was not written with symbols. It was written with numbers and geometry. For a very long time, mathematics was deeply connected with geometry. People did not think of x squared as just a symbol. They thought of it as the area of a square. If the side of a square is x, then the area is x squared. That is why completing the square made so much sense. Suppose we have an equation like x squared plus 6x equals 16. An ancient mathematician would not just move terms from one side to another. They would imagine a square of side x. Then they would add rectangular pieces around it. And finally, they would complete a bigger square. This visual thinking was powerful because algebraic symbols had not yet developed. So before equations became lines of symbols, they were pictures in the mind. Now the story moves to India. In the 7th century, the great Indian mathematician Brahmagupta made important contributions to algebra. He worked with rules for solving equations. He also helped develop a deeper understanding of zero and negative numbers. This was a huge step because to solve equations more generally, mathematics had to become comfortable with different kinds of numbers. Positive numbers, 0, and eventually negative numbers. Brahmagupta's work helped mathematics move from purely geometric thinking toward more general algebraic rules. It was not yet the exact modern quadratic formula as we write it today, but the direction was becoming clear. Mathematics was slowly moving from shapes to rules to algebra. Now we come to one of the most important names in the history of mathematics, Al-Khwarizmi. Around the 9th century, Al-Khwarizmi wrote a famous book on algebra. In fact, the word algebra comes from the title of his work, and the word algorithm comes from his name. But even Al-Khwarizmi did not write equations like we do today. He used words. For example, instead of writing x squared plus 10x equals 39, he would describe it in language as something like, a square and 10 roots are equal to 39. Here, square meant x squared, root meant x, and number meant a constant. Al-Khwarizmi classified quadratic equations into different types. For example, squares equal roots, squares equal numbers, and squares plus roots equal numbers. Why did he do this? Because negative numbers were not accepted in the same way we use them today. So he handled different cases separately. And again, his method was based on completing the square. So look at the journey so far. The Babylonians had practical methods. Indian mathematicians expanded the idea of numbers. And Al-Khwarizmi organized algebra into a systematic subject. This was a turning point. Quadratic equations were no longer just practical puzzles. They were becoming part of a bigger mathematical language. But there was still one big problem. For a long time, equations were written in full sentences. Imagine solving mathematics without symbols. No x, no equal sign, no plus sign, no formula. Everything had to be written in words. This made mathematics slow. It also made it difficult to see patterns. But slowly, mathematicians started developing symbols. Unknown quantities began to be represented by letters. Operations became symbols. Equations became shorter, cleaner, and more powerful. This changed everything. Because once you have symbols, you can stop solving only one problem at a time. You can start creating general methods. And that is where the modern quadratic formula begins to appear. Today, when we see a quadratic equation, we write it like this: x squared plus bx plus c equals 0. And we solve it using the famous formula: x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. At first, this formula looks scary, but it is not magic. It comes from the same ancient idea: completing the square. Let us understand the basic flow. Start with x squared plus bx plus c equals 0. Move c to the other side. Then divide everything by a. Now the equation becomes ready for completing the square. After completing the square and simplifying, we get the quadratic formula. So the same idea used by ancient mathematicians is still hidden inside the modern formula. That is the beauty of mathematics. The language changed. The symbols changed, the notation changed, but the core idea survived. Now look inside the formula. There is one very important expression: b squared minus 4ac. This is called the discriminant. The discriminant tells us the nature of the solutions. If b squared minus 4ac is greater than 0, we get two real solutions. If it is equal to 0, we get one repeated real solution. And if it is less than 0, we get complex solutions. This is a modern way of understanding quadratic equations. Ancient mathematicians did not express it like this, because complex numbers came much later. So the quadratic equation kept growing. First, it was geometry. Then, it became arithmetic. Then, it became algebra. Then, it became a symbolic formula. And later, it connected with real and complex numbers. Now you may ask, why did humans care so much about quadratic equations? Why did this one type of equation survive for thousands of years? The answer is simple: because quadratic equations appear everywhere. In physics, when you throw a ball, its path is often modeled by a quadratic equation. In architecture, curves and parabolas appear in bridges and structures. In economics, profit and cost problems can become quadratic. In computer graphics, quadratic curves are used in design and animation. And in competitive exams, quadratic equations test logic, speed, factorization, and algebraic thinking. So quadratic equations are not just school exercises. They are one of the first places where mathematics teaches us how to understand shape, motion, change, and optimization. So the next time you solve x squared plus 5x plus 6 equals 0, do not think of it as just a textbook question. Think of the Babylonians writing on clay tablets. Think of ancient peoples solving land and area problems. Think of Indian mathematicians expanding the idea of numbers. Think of Al-Khwarizmi organizing algebra into a powerful system. Think of centuries of mathematicians slowly turning words into symbols. And then, look again at the modern formula: x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. This formula is not just a shortcut. It is a compressed version of thousands of years of human thinking. Quadratic equations are not just equations. They are history, written in symbols. If you want more stories where mathematics becomes visual, historical, and meaningful, then follow this series. Because mathematics is not only about solving questions, it is about understanding how human beings learn to think.